Today we're going to start Chapter 2. So in Chapter 2 we're going to talk about sets. If you happen to take 97 last semester, we kind of introduced some of the topics that we're going to talk about this semester, but we're also going to explore all of these ideas a little bit more in depth. Before we get started in Chapter 2, we're going to go through and just kind of talk about some vocabulary and some different things that we need to know before we jump into our different types of examples that we're going to be working through. Okay. So to start with, some definitions. A set is a collection of objects, right, which are called elements or members. Right. So the things that are in our set are called elements or members. They could be numbers, they could be words, letters, symbols, whatever the case may be. They're just whatever is belonging to our particular set. A set is said to be well defined if its contents can be clearly determined. In other words, the contents can be clearly named, listed based on fact and not opinion. So when we're thinking about the word well-defined, which is going to be the first example that we're going to be looking at, sets are well-defined if they're based on fact and not an opinion. In general, sets are named with capital letters. So we're going to have, maybe set A equals, and then have a set B equals, and then list everything that's in the set. So we're going to be looking at a bunch of different things as we start getting into this chapter. What we're going to start with, since we're thinking about our definitions for set, is we're going to talk about different methods to indicate a set. Okay, so there's 3 different methods commonly used to indicate a set. Description, roster, and set builder notation. Our description is exactly what it sounds like. We're going to use a phrase or some sort of description to describe our set. A roster form is a list. So it's just like a class roster is a list of all of the people in the class. A roster form of set is the list of all of our elements. They're generally separated by commas. When we're using our different forms of these sets, we're always going to have our set written in a set of braces, or a pair of braces, I should say. And then if we have an infinite set, we can add 3 dots in there to say that or to show that the set continues, whether it's a continuation in the middle of the set and or an infinite set where we have it continuing at the end, then these 3 dots are called an ellipsis. The other form of our sets that we're going to look at is our set builder notation. And what we see here is something that's a little bit more fancy and mathematical looking. So in this case, we have the set A, right? And then we have an equal sign, a brace, X, a vertical bar, X, and then followed by conditions or descriptions, and then we close it off with our other brace. So what we see here and how we read this, would be read as A is the set of all X. So this equals X means A is a set of all X. This vertical line here means such that, and then we insert our conditions afterwards. So we'll definitely be going through examples, looking at these different methods to indicate our sets. Okay. Again, in this first very little bit here, we're just talking about some definitions. So we've seen our definition of set, our methods to indicate set, and then down at the bottom here we have some helpful hints. So we want to go through and talk about some of this stuff as well. All right, so when we're looking at these helpful hints, again, we usually use uppercase letters to name sets, as we see in that set builder notation above there. That weird little looking E symbol means is an element of. Right. And remember, elements are things that are in our sets. If we draw a line through that weird looking E, then it means is not an element of. Right? Just like we cross off or put a line through our equal sign to mean not equal. Okay. The next 2 symbols, we want to make sure that we know which one's which. So this first symbol means less than. Our first number is going to be smaller than our second number, or if we have X less than something, we're going to use this symbol. And then this next one is greater than. Again, we are going to be utilizing our less than and greater than symbols, so it is going to be important that you feel comfortable with which one's which. Remember that the smaller number is always towards the pointy end, and the larger number is always towards the open end of our symbol. Okay, a couple of other things, definitions to remind us of. The set of natural numbers. We use n for natural numbers. Natural numbers are sometimes also referred to as counting numbers. So we start with 1, 1, 2, 3, 4, 5, so on and so forth. Notice here that what we have is roster notation. We have a nice roster notation that includes everything, and it includes an ellipsis showing that this set continues towards infinity. The set of whole numbers. The only difference between our natural numbers and our whole numbers is we've added 0. So we start at 0 and then we continue counting. If we throw our negative whole numbers in there too, then we get our set of integers. Yeah, so we're just kind of slowly adding some different things. Then if we add in fractions and decimals, then we get our rational numbers. Here, notice that this is an example of set builder notation. Q, we use the Q for rational numbers because we actually use R for real numbers. So Q equals, it is the set of all x such that x, remember this symbol means is an element of A over B. So what we have here is a ratio. So x is a ratio where A and B are integers and B does not equal 0. What this does is it gives us a way to generate all of our fractions, all of our decimals, and actually we can also get all of our natural numbers, whole numbers, and integers as well by using and thinking about different denominators. So for instance, 5 over 1, right, is really just 5, which is a natural number, it's a whole number, and an integer as well. The set that contains no elements is called the empty set. Right, or null set. Right, and what we're going to see our symbol, we're going to use either an empty set of braces to say we have the empty set, or we take a 0 and we draw a line through it to show our empty set. Just one little note here, we don't want to put the 0 with a line through it inside our set because then it's not the empty set anymore. There's something inside of there. Right, so we're going to use, and you'll see me kind of use both symbols quite often, go back and forth between the two. So as we're going on through the rest of this section and the rest of this chapter, in all honesty, we're going to be using a lot of these definitions that we see on this first page. And then the rest of the examples for this section, we're going to be going through and kind of talking about and working through some of these different definitions and exploring some different things between our sets.